Ladies and gentlemen, welcome to the Ride and Ride Mechanic channel. How the heck are you doing today? Alright, today's video. Floorless coasters use these things. They're the robotic flooring. Well, B&M calls them robotic flooring. We call them the combs. So we're going to talk about how combs work on a floorless roller coaster. Let's get into it.
Now get ready. Here we go.
Alright, this is your first time to the channel. Welcome. I'm glad you're here. This is going to be a great video. So let's talk about this. Way back when, in the early 2000s, B&M messed around and made up floorless roller coasters. So this was a different concept. I don't know what this was like. It was probably like, hey, you know what? People like our roller coasters. What do you think we should do? Well, why don't we make an inverted roller coaster? Well, we've already made an inverted coaster. What else you got? Well, you know, why don't we use something like a sit-down roller coaster? It's like, yeah, but we've done that before. What do we do? Hey, I got an idea. Why don't we make an inverted roller coaster where the track is underneath? So that's just like a regular roller coaster. Like, what's different? No, you don't understand. The track is underneath, but people can see the track. Oh, okay. So it's like they're in a regular roller coaster, but there's no floor? Yeah, we'll call it a floorless coaster. It won't have a floor. Okay, all right, good idea. Well, but there's a problem. How do we get people in and out of the coaches if there's no floor? We'll use a movable floor, a floor that just vanishes right before the train moves. Okay, all right, we could do that. How? I don't know. Let's figure out like a robot. It'll just like a transformer. It'll just assemble itself and then take itself away. It'll be pretty cool when we're done. All right, that sounds like a solid idea. Let's build it. So what we got is roller coasters that don't have a floor. So when you come back in the station, the floor essentially has to be assembled underneath the vehicle. Now, this is a really interesting thing because since then B&M's come up with the dive coaster, which has a really big open area, and the flooring that they made for that, it does the same thing. It can assemble itself and then take itself away to allow the roller coaster to move, but it's not done in the same fashion. The older floorless roller coasters out there have a really complex system underneath there. B&M actually calls that entire system the combs, but when you look at it on like their design prints, it's called robotic flooring. So the same thing, but everyone refers to them as the combs because it looks kind of like a giant comb. They basically look like a big sheet metal pan with 8 openings in them, or 7 depending on the size of the roller coaster, multiple openings inside of them. But basically they all do the same thing. They allow people to get on and off the roller coaster, and they all perform the same way as well. So let's talk about that. The comb underneath there is assembled out of, it's basically like steel with plating aluminum on top of it. That's the grip surface that you're actually walking on there. Now, one of the things that has to be achieved first in order for this whole thing to work is the train has to be homed. So when the train comes in, it's going to have to home itself. Now, what's different from that from a lot of other roller coasters? Well, floorless roller coasters have to be in an exact spot. They've got to be within just 3 or 4 millimeters of where they're supposed to be every single time. Why is that unusual? It's not really unusual. For rides like LIM and LSM style rides, they can home themselves just like a floorless can in that little tiny little window that they have to stop in. But when you're talking about older rides, I'm talking aerodynamics, I'm talking just older stuff, even B&Ms that come into the station, they typically come in, they slow down to a stop, and there's a bit of a drift. They can drift forward by an inch or two or backwards by an inch or two, depending on the load, how many people are inside of it. But the floorless can't handle that. In order for B&M to put the floor up and create this nice safety barrier for you, it's got to come up within a very close proximity to the train all the way around, which means they can't afford to have the train out of position at all. The train has to be in this exact spot. So the floorless coasters have a more complex homing sequence to bring the train into position. So what it does is as the train comes in from typically the transfer track or the brake or however the ride might be set up, it comes in at a fast rate of speed, hits the proximity sensors mid-station, the drives in the station slow down to about 30%. As the train slows down to about 30%, it crawls forward just a little bit more and then hits another set of proximity sensors where it slows down to 5% and then inches forward until it hits the final proximity sensors, and then the drive cuts off. The station is officially home. Now the combs are allowed to work. So let's talk about that function real quick. Okay, the function of the comb itself, it happens in 4 steps. The combs are not a singular piece on each side, a left and a right side, nor do they work in unison, i.e. they're not tied together in the middle. So basically what you have is typically for 8 coach long rides, you typically have one comb that covers 2 coaches. So you have comb number 1 on the right hand side will cover the front of coach number 1, let's say right side, coach number 2, right side. On the left-hand side, you have another comb sitting there. Every one of these is independent with each other. So you have 1, 2, 3, 4 on the right side, 1, 2, 3, 4 on the left side. You have a total of 8 combs that work with each other. Now, they all function in the same exact process. So they all go, there's basically 4 steps to the function when you're dispatching a train. They start with the top, which is the level, and they say level down. Then they say comb open, and then they say level up, and then it says air lockout. So you got level down, comb open, level up, air lockout. We'll talk about why these are necessary for each one. And then on the left side or the right side, whichever one it is, it does the same exact thing on there. Now, the way it gets its position feedback of the comb assembly on the big air cylinders that are underneath there, the whole thing is pneumatically operated. They use reed sensors on the side of the cylinder. So you'll have a cylinder kind of like this, but the ones underneath there are much, much bigger, much, much bigger. So it uses basically on the piston on the inside, there's a magnetic ring that goes around the piston. So they use a small sensor on the outside to tell it when this is down at the bottom or when it's up at the top. So it knows exactly where that is. So it's done all off of feedback, and each one is independent. The whole thing looks like it's working together in unison all at once. But realistically, it's 8 individual commands happening, or 8 individual up and down commands, happening at each particular moment. So it looks like it's working together, but it's not. If you were to, for some reason, hang one of those combs up and prevent it from operating, everything else would still continue to open the way it is, except for that one. It will stay in its position or not do something. We'll talk about troubleshooting them later on. So as I said, the method for powering these things is pneumatic. It's compressed air. Why? Compressed air systems work great. They're able to be quick acting. They're lightweight. It's not a bunch of heavy mechanical stuff. Hydraulic cylinders they're very heavy. There's a lot of weight to them. You need a hydraulic system, and then you need something to contain all the hydraulic fluid that will eventually leak out of the system, creating a big environmental impact that a lot of parks don't want. So pneumatics can just run quicker than the hydraulics can. So they use pneumatic cylinders out there for ease. We already have a compressor running everything else on the ride. Just run a big compressor right to the bottom of those combs, and they'll work the same exact way. All right, so let's talk about an interesting feature of the combs. With the combs up, they are actually locked into place inside of the station. You may say, like, well, what does that mean? If you see the combs up in the station with a train sitting there, the comb itself is level with the outside of the station. Now, the station has a sheet metal, it's actually a steel nose along the inside of the station, but the way the comb is put up and assembled in place underneath the train, the comb is effectively pinned between the train and the station, meaning it can't accidentally slide out of there. Even if you were to somehow give it the down command and tell the main cylinders to pull down to open the combs up, it can't do it. It's pinned in place. It's a very interesting thing. Also, the cylinders are put in such a way where they typically rotate and lock into place. So once the cam is rotated into place, pressure down on there is evenly acting across the cam, which means that even with no air pressure, the combs will stay up in place. Is there a chance that the comb could fall with no air pressure? Yes, there is. There's always that chance. So if one of those cams didn't go all the way and lock 100%, it's up high enough to where the proximity sensors say it's all good. But if you were to lose all air pressure and the ride completely bled all of its air pressure out of there, there is a chance that that comb could then unlock and fall down. Not a great scenario. They don't want that happening. There's some safeguards against that in general. I just wanted to add in here that if you're a mechanic working on this and you haven't done this already, if you adjust any of the adjuster rods underneath one of the combs, like in this picture, they're blue and they're red, and there's a couple more in there, not in this side, but if you adjust any of those, even just by a millimeter or two, that whole thing will lock up most of the time. You have to be very, very careful with all those adjustments, just a FYI. So let's walk through the 4 steps again of the operation of the comb. Let's talk about all of them put together. So we start at the dispatch process, and we're going to say we're ready to dispatch. All the safeties in the station are made, air gates are closed, restraints are locked, and we're ready to dispatch. What are the commands given? The first one is level down. Now, as you're sitting in the train, the level is actually the piece that you walk on. It's the top of the floor. That's what they call the level. The level is the piece that creates the floor itself underneath you that you can walk on, you can touch. It's physical. That's where it is. The first step is that level comes down. It comes down about 4 to 5 inches just to clear the edge of the nose on the station. So you'll see them fall down about 4 inches, and then that's what's called the level down command. Now, the next step is that now the comb is out of the way of the train, which is great because that's where the clearance envelope is. That's where your feet swing, so they want to make sure it's clear of your feet first. Once it's down, the level is down, next thing they have to do is comb open. Now, on the side of the combs, there are 2 very large cylinders. They're about 4 or 5 inches in diameter and roughly 4 feet tall. Those combs, those are extended all the way up in the up position. Well, those retract and pull those combs open. Not straight down, they pull them open like a lever off to the sides underneath the station. That is the comb down command. So the first thing it does, it goes level down, and then it goes comb open. So the comb open is necessary to clear the majority of the train. So if those upper levels, the wheel carriers would still run into them. So it has to go level down, wheel carriers will still hit them, and then it has to go comb open. Now the wheel carriers won't hit them immediately, but they're still underneath the station, and the wheel carriers will still hit them down there. The foils will on the side, actually. So they're still not out of the way. So what you have to do to get them out of the way is you have to give them the level up command again. So it goes level down, so do both of them, sorry. Level down, comb open, level up. So they go down, open, up. That last up is what creates the clearance envelope around the wheel carriers itself to allow the train to roll forward. That's what's necessary. So the last step in this entire process is to do an air lockout. Now, normally on valves, you use valves which are considered normally open or normally closed. So there's 2 states to a valve. They're typically called a 2-position valve. It's either in position A or it's in position B. Now, on safety cylinders like air cylinders, you might need to stop them for some reason and you don't know what's going on. So you don't want to continue the command because air pressure is not forgiving. So what you do is you say, I want to go up, and if you suddenly go up and there's a problem, you want to stop that problem. Well, sometimes you don't want to reverse the direction. You don't want to say go back down. That might make the problem worse. So you lock out the air cylinder wherever it is. How do you do that? Well, you use what's called a 3-position valve. So the center position can be set up lots of different ways, but in this case, what they do is they make it into neutral. They essentially bleed the air out of everything. So they've already designed it in such a way to where when the combs are open, everything is retracted. The main cylinders are retracted. They don't need air pressure anymore. The level up has been given, and those cams have been locked into place. So they're mechanically locked into place now. So the level up doesn't need air pressure anymore either. So what you'll hear when you dispatch the train is you'll hear it go level down, comb open, level up, and then you'll hear a bunch of air from underneath the station release. That release of air underneath there was all the air in that comb assembly has now been bled to atmosphere, and the comb is essentially locked out at that point. It can't go anywhere. It can't go up or down. It does not have the air pressure to do so. So for those 3 position valves you have, let's just use up and down to make it easier. There's actually a series of 3 valves underneath on each side, 4 on the other side. We'll use up and down just to make it easy. We'll say position number 1 is up, position number 3 is down, but position number 2 is locked out in the center. Now, locked out, you can make it any way you want to, but typically what it's done is it's capped. It just takes the ports from the cylinders and caps them, and then bleeds the air that was on the other side. It just bleeds it out the front. So you'll have capped, and then the air is bled out of line, so it can't go anywhere. In a power failure, those cylinders go back to their neutral position. It caps it, and then bleeds the air out of there because it doesn't know what the ride doesn't know what is going on. So it just kicks that whole assembly into neutral, because if it was up, that's fine. It's neutralized in the up position. If it was down, that's fine. It's neutralized in the down position. If it was in transit, if it was opening or closing right during the power failure, it locks it out wherever it sits, and the whole comb assembly essentially freezes wherever it was, whatever it was doing. It just kind of stops right there in position. Now, one of the sides carries an extra valve, like I was talking about. One of the extra valves is carried for the unlock mechanism. So on your standard roller coasters, on your invert roller coasters that B&M makes, they use a mechanical unlock to actually push on a lever to open the restraints. Well, that comes from the combs. It's not in the station anywhere. It's actually mounted onto the comb. It's a release platen that sits there. It's 2 small little air cylinders that move a uniform bar on top and push it up underneath the coach to unlock the restraints. Now, older rides, you could see this up on top. Sometimes you'll see, like the old Vecoma's Arrows, there's a big bar in the station that all comes up at the same time, because you have on the side that unlocks, because their unlock mechanism is only mounted to one side of the train, you'll have actually 4 individual unlocks. That's the reason why at the ride operator panel, they can say unlock 1 and 2, because it's controlled on one comb. Now, you could split that function apart further if you wanted to add another valve into the assembly. I've never seen a park do it, but it might be out there. And where you could say just unlock 1, unlock 2. But a lot of times that's too much, so they don't want to do that. They just say unlock 1 and 2, 3 and 4, 5 and 6, 7 and 8. And that takes care of the unlock commands for the thing. So let's talk about the safety around the comb assembly now. So the combs are a very hazardous situation to be around when you're talking about workers in the area, being the ride operators in the area. You literally have an open hole in the ground that somebody can fall through. So they want to make sure that nobody's around there. So typically operators have to stand behind gates. They have to be in areas where they're holding buttons while the thing is operating. So when they looked at the possibility of ride operators being hurt doing something like that around the train, the number one thing that came up with them must have been that there was somebody around the train and they moved it. Now, this is a serious problem because typically you have multiple ride operators working around the train that are supposed to be given an all clear. You know, when they go to dispatch, they make sure there's nobody on either side of the train before they press those buttons. Sometimes that doesn't happen, especially when you're in like a manual mode or maintenance mode. If I'm up there by myself and I'm running it, I will before I dispatch, I will literally walk across the train and look on the other side since I can't see it. And then I'll walk back up to the operator panel. I could dispatch a train by myself because I have the keys in that allow single point dispatch. So what the manufacturer did in order to prevent people from falling into these open holes while the train may or may not be moving is they've layered the sides of these things with light curtains. So what's a light curtain? A light curtain is a sensor, is a beam that runs from one side of the train to the other. And they're basically flat. There's a whole bunch of beams that basically make a flat beam of light that goes all the way down the station. It's not vertical, it's actually horizontal, and it sits right above the floor. So what it's looking for somebody standing over there. One thing that happens all the time is you might see trash. I know I was at Magic Mountain and I was up there and the ride operators had some paper cups and it was sitting down and the cup was blowing around because it was kind of windy that day. It was blowing around right next to the light curtain. I'm like, oh man, as soon as it crosses that light curtain, the combs commands will stop and motion commands will stop, which means if you're dispatching the train, it'll stop the train on the way out of the station, way into the station, until that problem is resolved. That guy will flag the light curtains and shut the ride down. So you've got to be careful on windy areas about trash floating around where the light curtain is. By the way, that's the light curtain. So you got to keep the light curtains clear. But the light curtains is what's the confirmation for the ride that nobody is next to this train or even close to this train when it drops the floor out from away there. They're mainly for the purpose of dismantling and reassembling the floor. Also one of the reasons why they don't like you to carry stuff onto the ride, because all the time people would take a hat off or something and try to throw it, and it doesn't go that far. It only goes about 1.5 feet away, which clears the train, and then it won't clear the light curtain. It lands in the light curtain, prevents everybody from dispatching. So the operators have to go out and clear the hat out of there and before it can go on its merry way. One of the things I found interesting on the assembly, and I'm not sure if they made this way or if it was just a byproduct, the way the cam is underneath the level, we're talking about the first part that sits underneath your feet, the levels down, the way the cam is set in underneath there with the little cylinder that pulls it down on one side and another one that pushes it up on that side, the way they're set into there, it appears that if you stand on top of that, it puts enough pressure on that cam in the center to where that cylinder can't overcome that weight to unlock it. Now, we never really tried that because we didn't want to be in a part of a moving assembly when it activated. That's like bad news all the way around. I had a state inspector try something similar to that one time. This is where he claims I almost killed him. that was a different story. Maybe I'll tell that later. Anyways, I thought that was an interesting thing. The way it looks and the way it's kind of designed in there, because it's designed to basically, it locks onto itself so it doesn't need air pressure to hold it in the up position, assuming everything is set properly. So it's one of those things that needs a lot of pressure to unlock. So I was like, well, that means if you're putting pressure on that, that little tiny cylinder can't overcome that and it won't unlock. Maybe if somebody out there has experience with it, tells me, can you drop the combs with somebody standing on top of it? We never tried it. It's not in the manufacturer's manual to try it, like put weight on top of it and drop it down. It's not recommended or anything, but I kind of think the combs won't unlock if you're standing on top of them, or one comb at least won't unlock if you're standing on top of it. So while we're talking about safety, let's talk about the functions of that. Okay, so in the back of the station, typically, it's at the back operator's panel, one of the two or three maybe that might be sitting back there. There's a button on there, and someone contacted me about this because they were an operator, I think they were new at the ride. Maybe they were in the process of being trained on the ride, and no one answered this question for them, so they contacted me and say, hey, there's this button back there called Combs Enable, and the thing never blinks, it's never on. What is that for? Because they had never seen it be used at that point. Fair enough. That is part of the comb safety system. Now, each comb has its own independent safety system, independent of the ride system and everything. Each comb has at the very front, right where the comb meets the leading edge of basically the nose of the comb comes up and hits the train, gets close to the train, I should say. It's got this black rubber guard on there. It looks like just a piece of rubber that sits on the front of it. That piece of rubber, there's 2 of them on each comb, is actually called a pressure edge. If you don't know what a pressure edge is, it's a sensor that's sitting out there, and all you have to do is put firm pressure on it, and the signal will go high, and it will say it's got a problem. So each one of the pressure edges on all the combs are ran down to their own individual comb component, and they're run into the controller board for the comb. In this case, the PLC says, okay, combs up. It gives an enable and says, okay, go ahead, combs up, and it feeds all the power up to the up commands and down commands. But at each individual comb itself, on the controller board, that's where that command goes to, and it says go up, all the stuff. It's got all of its own feedback right there. Well, if you ever hit one of those pressure edges, or if there's something in the way, like the comb tries to come up and somehow someone's leg is down there. Not sure how this would happen, but there's something down between the comb and that coach. It will come up and it will hit that object, hit that pressure edge, and that board will fault. Now, when that board faults, it not only tells its comb to stop, and it locks itself out, it puts it back into neutral, but it does that for all the other combs as well. Because it says, I don't know what happened, but everything stopped. And it shuts everything down in the station. Well, it didn't tell the ride to stop. It just told the combs to stop. Now the ride is sitting there acknowledging that it's like, okay, there must be some sort of a problem out there. Interestingly enough, ours did not have a fault for this built in. So like if you were to hit a pressure edge, all the combs stop, but it does not trigger a fault. So comb stop, no fault. Okay, so you go out there, what's going on? All the combs stop working. So you look at the panel, no fault on the panel. You go into manual mode, can I move the combs up with manual mode? You just hit panel view enable and say combs up. Nope, can't do that. Combs down? Nope, it won't go either way. So I have mechanics get frustrated and they're like, I don't know what's going on. They won't go up, they won't go down. There's no fault. I've tried resetting it. I've tried doing all this other stuff. It's the independent safety system. That's what's going on. So I say, oh, look at the secondary, which is officially for ours, it was the back corner, like kitty corner to the main operator panel. I said, look at the back operator panel over there. The very, very, very bottom light is a combs enable button. It's a green button. Is it flashing? Or it was blue, I'm sorry. Was it flashing? And they go, oh yeah, it's flashing. Okay, go over there and push the combs enable button. So what happens is when you trigger one of those pressure switches on the side of the comb, it shuts off the safety system for the combs, or triggers the safety system for the combs. The only way to reset the safety system for the combs is through that combs enable button at the back of the station. I thought that was really interesting. I'm like, really? There's not another one on this side? There's not 2 of them? There's not one at the main operator panel? There's not something that tells you, hey, the combs ran into something, you might want to go check that out. Nothing. It was a completely dead system just sitting there except for the one blinking light in the back. Now, it talked with it somehow because the ride PLC controlled that blinking light and that button. It wasn't the combs. So the combs did talk somehow, but they didn't. The programmer at the time did not visualize that to the main operator panel. So where you had a fault or something else that you could see. I think at this point in the video, it's at least an honorable mention. They're not really part of the comb assembly, but we're going to say the cattle gates. That's these big finger-looking gates out in front of the roller coaster here. The very front, they open and close to allow the train in and out of the station. But the cattle gates are necessary just to keep people from falling off the front of the station. I know on our inverted roller coaster, our safety person one time discussed about putting cattle gates on the front of that so people didn't come off of there as well, but we never had a problem with it at all, so we didn't do that. But The cattle gates are simply just a pneumatic ram underneath. They're essentially oversized air gates that work on the ride. And they're used a lot in the other coasters as well. So for the floorless roller coasters, there's a lot of little tricky pieces to them in and out. One of the things that you'd have to do all the time is you'd have to add plenty of oil to the combs to make sure everything was moving in unison. You'd have to spray lubricant everything underneath there, and then, oh my gosh, everything that washes out of the station ends up in those combs down there. So you, like, on the bottom side, they're just covered in dirt and everything else, and there's hair hanging down from them. There's a big net underneath the station too. Typically, on most of the rides, there is a giant net underneath the station. Now you might say, like, people that have seen this net down there, you might have noticed it. It's like, well, what's the net for? Is that to catch hats and sunglasses that might fall out down there? Nope, that is a worker's safety net. That's what that is. So underneath the combs, underneath the station, those stations are actually fairly high off the ground. There is a platform underneath there that allows workers like myself to go up there and lubricate and oil the combs and check all the componentry, the sensors, and everything else that might be in there. Well, I need to get close to that. Well, there's nothing guarding that area. It's in a restricted area, so like I have to have a key to go in there. But there's nothing else in there. There's no sensors or anything down there that just says, hey, stop if I get too close to this robotic floor that could easily crush a person. So, okay, remember, there's no pressure edges on the outside in the downward travel. If you sit too close, you're crushed. There's nothing you can do about it. So what they did is they put a net on the outside. Basically, it's the comb's clearance envelope underneath the station. They put a net all the way around the thing, and they anchored it in there pretty good. And whoever did that did a really good job with it. I'm not sure if it was a manufacturer or if the park I was at had another company do it, but it's a really stout, tight net that's really hooked in there really good. You really have to, like, when you're troubleshooting stuff, we would stand underneath there and we would watch the combs working. And as the combs were working, you couldn't get closer than the net. So if we wanted to like push on something as it was doing it, you could try pushing the net forward and then like pushing your hand up to try to see it over there. Or you could just get a long stick and kind of go through there and touch it. Because sometimes it helps to feel, pneumatic valves and stuff like that. When they start messing up, you might be able to feel that one valve is really hot versus the other. You might be able to feel it like a buzzing or a vibrating, or sometimes you could hear it. But when you hear a buzzing coming from a valve panel, it's hard to tell which one is buzzing. So you typically use something like a screwdriver or a mechanic stethoscope, and you put it right up against the valve to listen to it. So then you could hear, like, I could hear the humming. I hear the humming. It's like, ooh, that one right there. It's really loud coming from that one. Because these things had, an upper and a lower and all these other stuff. So there was a lot of componentry underneath there to troubleshoot when it went bad. Not to mention it's all PVC hosing that ran all the pneumatics and everything. So they had extra valves on top of the valves that ran the up and down level commands and stuff like that. They had other valves that go into each cylinder that were like pilot operated throttle valves. So it's like it was free flowing in one direction, but when you removed air pressure, it was locked. So you actually had to put air pressure back into that valve to get it to unlock to flow the opposite direction. It was some really interesting thing. The whole thing was all Festo components underneath there, or at least it was at the time. There was a lot of custom, interesting stuff underneath that comb assembly for sure. And then we'll quickly talk about going back in. So the combs are open, they're enabled, they're locked out, they're in the full open position. The train's free to go in and out of the station. So it's very simple. You send one train out, bring the next one back in, just like I explained earlier. You have to bring it in and slow it down and then slow it down again and get it into its exact little, it homed within 2 millimeters each time, which was pretty impressive. So you bring it back into its little tiny narrow little window and you stop it right there. Then you give the comb up command and everything comes back up. Now the levels up at the very top, you used those reed switches all over all the cylinders to say whether the cylinder was up, down, in and out, whatever it needed to be, except for the level up. The level up, they used a normal barrel proximity sensor on the side with a flag that was hanging off the level up that looked like a J. So when the level came down, the sensor would say like right here, and then when the level came up, it went right in front of that sensor again to flag it and say that the level was in the full up. Now, I think that one also had reed switches on the cylinder as well for that up and down command, but I think they just wanted another form of verification that everything was up. And then when it came to the restraints, the ride wouldn't unlock the restraints unless that platform was in the full up position, locked, and everything was ready to go. Oh, and the story about the state inspector. I've said this story before, so some of you older subscribers might remember this. Newer ones probably haven't heard this one yet. We were doing testing at our floorless roller coaster, and the state inspector was walking around up there. Now, this particular state inspector, he loved to stop the ride out of position. He loved to stop the train short, stop it in the block. He loved to have us flag proximity sensors and do all sorts of things, trying to get the ride to fail in some sort of unusual way. He was trying to find a hole in the system where it's like, oh, if you do this and you do that, like you don't even have to press reset and the train goes right through. It's like, we never found anything like that. So he was up there one day, and this is not his first rodeo. He's been doing the inspections at that park for a long time. He was up there one day with me, and I was moving the train out of the station. So we were talking about the combs and everything else. We were just talking about the combs and the light curtains and all the safety. And I was bringing the train in, and it stops, and the combs come up. The combs came up, and they went to level up, and then he broke the light curtain. By breaking the light curtain, I just mean he stands in the way of it. So the light curtain goes high on that side, and it says, whoop, and the combs stop. So they come up just about an inch short of being all the way up, and they stop. And I'm like, okay. But I don't ask him. I don't say, what are you doing? Why did you do that? Why did you stop the combs out of position? He just goes, crossing. I'm not even thinking about it. I'm confused as to why he's testing this. I was like, okay. I was very confused. I was like, well, all right. And that's what I did too. I said, all right. And he proceeded to cross the train. He stepped on the first comb, and that comb fell down. Not all the way down and open, but it fell down, and where he death grabbed the seats on both sides to prevent himself from falling down with it. And then he proceeded to get very upset with me about why I let him do that. And I was like, I thought you were just testing this. And he's like, no, I wasn't. And we had a good long argument about that, which the outcome of that was simply like, okay, in the future, and we kind of wrote this down too, said like, all right, in the future, anytime you test or do something out of position, I said, I want you to tell me that you're testing it. Otherwise, I'm going to assume you're not testing it and you don't know what you're doing. At the same time, anytime you stop something out of position, we are going to tell you that is not in the correct position. It's not in the home position. The train is not where it's supposed to be or something. So you can acknowledge that at will. It's like, okay, we both agreed in that. That was a near miss. We both agreed that we both had equal parts to do on that one. It's like, okay, he interrupted the cycle, but I thought he was trying to do something when he wasn't, and we had that near miss in between. Luckily, nothing happened. He was okay, everything else, but I don't know. That was an interesting one. All right, I think that's going to do it for this video. Not a very long video this week, but that's okay. Like, subscribe, share, do all that stuff. It does help me out. I do appreciate it. If you want to contact me, you can always just try it in the comments down there. That's perfectly fine. I do have an email address too. It's ryantheridermechanic@yahoo.com. You can always email me if you want to ask something. People ask questions all the time because they work at parks and things and want a more secluded answer just from personal experience, which is perfectly fine. I'm willing to help out wherever I can, you know? All right. That's going to do it. Stay off the air gates.